right. So, just to continue, now that we know how to determine if we need to make a change in dose rate or dose interval, is this sharing? Sorry. Since we know what we need to do, it's correct, right? I'm capturing that. Sorry. Okay. Since we know what to do how we actually alter the dose rate or the dose interval, now we have to think about the fact of other things that could come in to change the CSS average or peak to trough ratio that would result in a problem for the patient. So if we have a change in things that affect or determine the CSS average, which is bioavailable dose rate, or a change in clearance, we know that that could increase or decrease our CSS average. And then how do we respond to that? Same thing, if we have a change in our peak to trough ratio, how do we respond to that? Well, we know what we control is the dose rate, the dose interval, and therefore the dose. So that's what we control as pharmacists. What we do not control is the clearance. We don't control kidney function. We don't control the liver enzymes. We don't control blood flows. So we can't turn up or turn down the clearance. We don't control the clearance, but clearance may change. We do not control the volume and distribution of the drug, where the drug goes and where it doesn't go. We don't control that. But we have to respond to changes in the volume and distribution. We also don't control bioavailability. Bioavailability is the fraction of drug that's taken that reaches the systemic circulation. We don't control that, but we have to be able to respond to changes in bioavailability. So we do that with changes in the dosing regimen. So let's talk about some of these possible situations. So how do I advance the slide? What if a disease or drug causes changes in the bioavailability, which is symbolized by the big letter F, volume distribution, which is a V, or clearance, which is abbreviated with the big letter C and L? These are the things that we don't control, but they may change in your patient due to other drugs or disease states. So a change in bioavailability will alter the CSS average, not the peak to trough ratio, because remember the determinants of CSS average are bioavailable dose rate. So a change in bioavailability will change that drug in or bioavailable dose rate. So an increase in bioavailability will increase the CSS average because it's just like giving more drug. A decrease in bioavailability will decrease the CSS average because it's just like giving less drug. It will not affect the peak to trough ratio. A change in volume and distribution will alter the peak to trough ratio. If you have an increase in your volume and distribution, the drug will be able to is able to distribute further out into your tissues, etc. And therefore it's going to take longer to get rid of the drug. And therefore the slope of your elimination curve is going to get flatter. So what's going to happen to your peak to trough ratio is going to go from this to this. So your peak to trough ratio goes from this to this. So it goes from larger to smaller. So a larger volume of distribution will make your peak to trough ratio smaller, won't it? And therefore, you may need to extend your dosing interval to respond to that. But that change in volume of distribution will not affect CSS average. It will only affect your peak to trough ratio. So change in bioavailability affects CSS average, not peak to trough ratio, and therefore will cause a need to change in dose rate. And a change in volume will alter your peak to trough ratio, but not your CSS average. So you'll need to make a change in dose interval, but not your dose rate. Finally, a change in clearance will alter both CSS average and peak to trough ratio. Recall that CSS average is determined by bioavailable dose rate over clearance. And therefore, if there's a change in clearance, you're going to see a change in CSS average, and therefore you're going to need to change your dose rate. And also, if there's a change in clearance, it's going to change your peak to trough ratio. If your clearance increases, the drug is going to be removed more quickly, and your slope of your line is going to get steeper. So you're going to see a change in K, or a change in your elimination rate constant, and therefore a change in peak to trough ratio. So you'll need to alter your dose interval to accommodate that. So you're going to have to change both dose rate and dose interval. Sorry, I gotta get an annotator here. Okay, so both CSS average and peak to trough ratio, therefore you're going to have to change dose rate and dose interval, aren't you? Bioavailability, you're going to have to change just will alter your CSS average, therefore you're going to need to change dose rate, but not dose interval. And if there's a change in volume distribution, it's going to change your peak to trough ratio, therefore you're just going to have to change your dose interval. Maybe I have to take that off text. Sorry. No, maybe not. Sorry. Oh, I got it to go. Okay. So now, this is a circumstance. I'm going to go back to my annotator, that we have a decrease in bioavailability. So there's less drug making it to the systemic circulation. So this blue line is our initial situation. So we are, the blue line is we're giving 250 milligrams Q6 hours. So the dose rate is 1,000 milligrams per day. I like to put things in milligrams per day so that it's just easier for me to multiply. So 250 times 4 is 1,000 milligrams per day. So the dose rate is 1,000 milligrams per day, and the dose interval is obviously 6 hours. So we're going along here with this blue line, and the CSS max is 2 milligrams per liter. The CSS average is 1.5 milligrams per liter, and the CSS min is 1.2 milligrams per liter. The peak to trough ratio is 1.67. But then what happens? We have a decrease in bioavailability. That's what this pink is. So we went from a bioavailability of 0.9 or 90% to a bioavailability of 0.45 or 45%. We are giving the same dosing regimen, 250 Q6. What happens? The whole curve falls, doesn't it? It's just like giving less drugs. So it's going to affect CSS average, right? CSS average is determined by bioavailable dose rate all over clearance. So if we decrease our bioavailability in half, our CSS average is going to be half of what it was. And as you can see here, our CSS average was 1.5, and it's now 0.75, exactly half. What do you expect? So we know that our CSS average has fallen. So what are we going to have to do? We're going to have to change dose rate for sure, right? We're going to have to change our dose rate. Now, are we going to increase or decrease our dose rate? Well, our CSS average fell, so we're going to need to increase our dose rate, right? We're going to have to give more drug to make up for this difference. What about dose interval? Do we need to change our dose interval? Where our peak to trough ratio here is 1.67. So 2 divided by 1.2 is 1.67. So when we have that decrease in bioavailability, we now have, I can't see what the Cmax is here, but it should be 1 milligram per liter. So it's right on the 1. So it's 1 milligram per liter, and the CSS min is 0.6. So again, the peak to trough ratio is still 1.67, which is what we would expect. We would expect the peak to trough ratio to stay the same. We haven't changed the slope. What changes the slope? What's the determinant of the slope of this line? Well, the slope of this line is K, which is determined by clearance over volume. Has clearance changed or volume changed? No. So our slope should remain the same, and it has. We haven't changed our dose interval either, so we would expect the peak to trough ratio to stay the same. And since the peak to trough ratio has stayed the same, we will not change our tau. And in fact, so we're going to stay at every 6 hours for our tau, but we're going to need to increase our dose rate. And since it's half of what it was, we're probably going to need to double the dose rate. So we're going to increase the dose rate to 2,000 milligrams per day. We're still giving it at every 6 hours. So what's our new dosing regimen going to be? It's going to be 500 milligrams every 6 hours because of this decrease in bioavailability. So we're going to increase the dose rate, no change in the dose interval. Let's advance these slides. There we go. All right, so that was a change in bioavailability. What if we have a change in volume of distribution? So in this case, we have decreased the volume of distribution. So decreased volume of distribution. So the drug has gone from a wider distribution into a smaller space in the body. It's going to be more in the plasma than in the tissues. We'll talk more about this in a week or so. And what that does is make the drug more available to the clearance organs. So if we decrease the volume, what's going to happen? Does it affect CSS average? Well, CSS average is equal to bioavailable dose rate all over clearance. Probably not, because volume isn't one of these determinants of CSS average. So we would expect the CSS average to remain the same. But how about the peak to trough ratio? Well, the peak to trough ratio, if you remember, is equal to 1 over e to the negative k tau. So we control the tau, right? So really the difference is if there's a change in k, which is the slope of this elimination rate constant, elimination line here. And K, if you remember, is determined by clearance and volume. So has there been a change in clearance or volume? Yes, there's been a change in volume, and the volume has decreased. So if we have a decrease in volume, we would expect the K to increase, which means it's going to be eliminated more quickly. So now let's look at our graph. So the blue again is our original, still getting 250 Q6. So the dose rate is 1,000 milligrams per day. And dose interval is 6, yeah? 6 hours. So our peak to trough, well, our CSS average, so what's happened? We've had a decrease in volume. We haven't changed our dose rate, but with the pink line, we've got that decrease in volume. And there's no change in the CSS average. The CSS average is 2.1 under both cases, which is what we would have expected, right? No change because none of these factors have changed. But what we would expect is for the slope of our line to get steeper. And as you can see, it has. So our peak to trough ratio has gone from 1.9 to 3.3 with that volume change. We can see our CSS max is higher and our CSS min is lower in comparison to our blue line values. So maybe we've got put us in the range of having toxicities here or lack of efficacy here or both. So we want it to look more like this curve as it was originally. What if we want that? What are we going to do? Do we want to change dose rate? How do we decide if we want to change dose rate? We look at CSS average. Has CSS average changed? Is it what we want? Our CSS average it has remained the same. So we're not going to change our dose rate, are we? But how about our dose interval? Well, it's gotten steeper. So what do we need to do to get our peak to trough ratio to be more like what it is here? Well, we need to chop this up into smaller pieces, don't we? We need to have less time for the drug to be being washed out here. So we're going to decrease our tau here. We're going to give the drug more often. We're going to chop that daily dose up into smaller pieces. So rather than we're going to stay at 1,000 milligrams per day, but rather than giving it every 6, we're going to give it every 3 hours. Which probably we're not going to do in real life, but anyway, we're just kind of giving some examples here. So we'd have to divide 1,000 by 8, right? Because if it's every 3 hours, it's going to be 8 doses. So what's 1,000 divided by, no, I'm sorry, every 3, yeah, it's going to be 8. So you're going to give, the new dosing regimen will be 125 milligrams Q3 hours. Sorry, I can't write very well. So our dose rate is going to remain the same. We're going to get the same amount of drug every 24 hours. We're just going to be chopping it up into smaller pieces. It's going to look more like a constant infusion, which is what we want because we want that less variation around the CSS average. All right, and last but not least, what about when there's a change in clearance? So again, in this case, we have a decrease in clearance. So that decrease in clearance, what's that going to do? Well, is it going to affect dose rate? Or I'm sorry, is it going to affect CSS average? Or is it going to affect our peak to trough ratio? Well, CSS average is determined by bioavailable dose rate all over clearance. So yeah, it's going to affect our CSS average. If we have a decrease in clearance, we're going to see an increase in CSS average, aren't we? What about peak to trough ratio? Well, remember the things that we're concerned about here is things that affect K or tau. So our K is determined by clearance and volume. So once again, clearance is a factor on both of these, right? So if we decrease our clearance, what's going to happen to the slope of our line? It's going to get flatter, isn't it? So our peak to trough ratio is going to decrease. There's going to be less variance, right? So if we look at these graphs, so our blue one is our initial dosing regimen, which is 250 Q6 milligrams Q6. So 250 milligrams is 1,000 milligrams per day is our dose rate. And our dose interval is every 6 hours. Right? So our peak to trough ratio, or I'm sorry, our CSS average is going to increase due to this decrease in clearance. And sure enough, our CSS average goes from 2.1 to 4.2. So we can see that CSS average increases. So what are we going to need to do? We need to decrease our dose rate. So we'll just say that we have to go in half again because this is doubled. So instead of 1,000 milligrams per day, it's going to be 500 milligrams per day. And our dose interval, as you can see, our dose interval has gotten smaller, so there's less variation. And that could be a problem in some drugs too. Maybe it's fine, maybe you can leave it alone, but maybe you can't. So peak to trough ratio here is larger than this. So how do we make this a larger peak to trough ratio? We extend the interval. We let it wash out long. We let it wash out longer. So we're going to increase our tau. Increase our tau. Our tau is now 6 hours, so we're going to now make it every 12 hours. So if we're giving 500 milligrams a day, and every 12 hours, our new dosing regimen is 250 milligrams Q12. That will bring down our CSS average and make our peak to trough ratio greater, which is what we want because of this decreased clearance. All right, thank you.